Okay, these STEM problems, science, technology, engineering, and math, um, it applies this math to chemistry in this case. Okay, so we're talking about in a chemistry lab, you use a paper filter cone to filter a liquid. The diameter of the cone is 6.5 centimeters and its height is 6 centimeters. How much liquid will the cone hold when it's full? That's essentially the volume. So we're going to do the formula for volume of a cone. Volume equals 1/3 area of the base, and since it's a circle, the area of the base is going to be pi times the radius squared, and then of course times the height. We'll fill in the numbers that we know. We don't know the volume, but we do know 1/3, pi is a number. The radius is half the diameter, so if the diameter, it says up at the top, is 6.5, then we're going to take half of that amount, which is 3.25, and we need to square that. And then times the height of 6. We have all the numbers we need to type into the calculator. So I'm going to do that right now. Let's see how we do. Okay, so we do 3.25. Square it, multiply it by 6, divide it by 3 to take 1/3 of it, and then multiply it by pi. Okay, it doesn't say what to round it to. Let's just round it to the nearest, let's round it to the nearest hundredth. I don't know what it's going to ask, so we say is approximately equal to, and we got 66.366. And again, if you were watching the other videos, remember what I said. If you're rounding to the hundredths, you underline that place. This is what I do. There's no special technique for it that's required. And then you look one more. Is that one more a 5 or higher? It is. So then the 6 we underline turns to a 7. So we say then the volume is approximately equal to 66.37. And they used centimeters, so we're talking about volume, so centimeters cubed. Yeah? That's the answer to that one. Okay, let's keep going. Now, since we're finding volume again, we're going to use that same same formula we used at the top. This cone has a filter that was being used to remove impurities from a solution, but became clogged and stopped draining. The remaining solution is represented by the shaded region. It's got a height of 2 and a diameter of 3. How many cubic centimeters of the solution remain in the cone? So we'll write that same formula. Volume is equal to 1/3 of the base, pi times the radius squared, times the height. Okay, what numbers do we know? Well, we have 1/3, we have pi, we know the radius. If the diameter is 3, then the radius is 1.5, and we're squaring that, and the height is 2. Okay, so let's type this all into the calculator. Just give me a second to do it. Do 1.5 squared times 2 divided by 3, and then times pi. It doesn't matter what order you do multiplication in, because there's the commutative property of multiplication that says you can rearrange the numbers. Then we get the volume is approximately equal to 4.712, and if we were rounding off to the nearest hundredth, say this is the hundredths place where the 1 is. Is that 2 a 5 or higher? It's not. So we don't make the 1 go up to a 2, we keep it as a 1. So we say the volume is approximately equal to 4.71, and they tell us that it was cubic centimeters. And that's it. That's the answer. I hope that was easy.